Hi, good evening, everyone. Yeah, I'll just wait for a few more people to join and then we'll get going with the session. Today's session is fairly straightforward. So, it is an extension of what we did last time. A week or so back, what we did was we sort of looked at a few sets. We looked at 4 sets basically from the past CAT papers. And we tried to see what it took to solve those particular sets. So today we are back with another session. Yeah. So we have 4 more sets today that we'll be solving. So we'll try to solve each and every one of them. Of course, if time permits, we'll be able to solve everything. Otherwise, we can solve 3 of them, and then you can do one more. That is completely up to us as to how fast we are able to do it. But then again, the point is not to solve sets in terms of numbers. The point is for you to understand what exactly does it take, right, to solve these kind of sets. So that is the whole idea behind having this session. So I'll just do one thing. I'll just share my screen. I'll just put the PPT in order, and then I will just share my screen once. All right. What we are going to do today is, again, as I mentioned, we are going to solve 4 sets. What I'll do is I'll just give a recap of the first bit, which I had done last time as well. So I'll just try to share a few thoughts on what exactly needs to be done to crack the DILR section. Of course, I'll not be spending a lot of time on that because we had done it in a lot of depth, right? Last time we had done it in quite some depth as to what exactly needs to be done, what do you need to do in order to score well at the CAT, and so on and so forth. So we'll not really get into those things again. What we are going to mostly focus on today is solving the sets. Yeah, I think we are good to go. I think the stream is also fine. Just give me a second. I'll just keep my the stream open on my uh, other system so that we are good to go. Yeah, I think we are fine. 2022 at the end, right? Arjun, we are not doing any 2022 questions today, as far as I remember. We are going to do 2017, 2021, 2020, and 2021 again. So I haven't taken any 2022 questions because last time some of you mentioned that you had 2022 left in terms of taking it real time and analyzing it. So I decided not to go for 2022 today. I went for 21, 20, 2019, and so on. I had also planned to take 2017 or so, but it's fine. So we are going to solve these ones. All right. So let's get going with the session. I think the stream is fine. So let's get going with the session. So I'll just give a quick recap of what we had discussed last time. So in terms of CAT 2023, what are the do's and don'ts that you need to focus on before you go for the actual test, right? So first thing is you have to set realistic targets. You can't go into a set thinking that you are going to solve each and every set, or if you have never solved even a single or you have never solved more than 2 sets in any mock, in even a single mock, you can't really expect to just go there and solve 3 sets or 4 sets at once, right? So that is one thing you have to keep in mind. Set realistic targets. Don't get carried away by what is all the noise that is going on around you. I'm sure your friends will tell you that they are able to solve 3 sets, all 4 sets. They can solve sets with time left, and all those things will happen. You have to understand what is your strength or what is not exactly your strength, and you have to play your game accordingly, right? You can't really get carried away and play others. So set realistic targets. The second thing is select your sets well. So we had done a bit of this thing last time, wherein I discussed the way in which you can look at these sets. So that is one thing. You have to select your sets well and ensure that you are solving the easiest 2 sets. If someone is targeting a 99ish percentile, the easiest 2 sets are the ones that you have to target. If someone is targeting a 90ish, 85 to 90 kind of a percentile, you have to do that one set which everyone is going to find easy, right? So that is one thing that you have to take care of. Beware of low accuracy sets. So I will solve one set. In fact, the first set that I'm going to solve is an example of the low accuracy set, possibility based set that I mentioned. So there I will talk about what exactly do I mean by low accuracy sets, because last time we didn't really cover anything which was low accuracy in nature. So we will look at a set in that direction today, right? Don't leave sets because of prejudices. So I had mentioned it in my LRDI traps video as well, that you are not supposed to leave sets because you don't really like a topic. You are supposed to leave a set purely because it is unsolvable and not a lot of people will be able to solve it. right? So that is the only reason why you should be leaving a set. You should not leave a set because you are not comfortable solving that particular set, right? So that is one thing. A hunt for value. So again, we will look at one or two sets today, wherein there are one or two questions that you could have solved even without solving the entire set. So that is what. So that is what I mean. Yeah. So that is what I mean when I say hunt for value. So one or two questions you could have solved without cracking the entire set. So that is what you have to hunt for. Once you're done with the easiest set, maybe hunt for those sets wherein you have one or two questions which you can target and solve quickly. And the last bit, guess theta's intelligently and hedge your position. So don't really guess theta's randomly, right? Just because there is no no negative marking for theta's doesn't mean that you mark whatever comes to your mind. Theta's are also a game that needs to be played intelligently. If you know that your answer is between 1 and 4. So last time we had seen one such set wherein we had discussed that set, and the pockets one, three pockets are there, three bags are there that contain certain number of coins. That bit we had done. So in one of the questions, you could have had 7 or 8 ones. Let's say, for example, I don't remember the actual numbers, but 7 or 8 could have been the answers. Then I will go with the assumption that there are 7 bags for one question. I will go with the assumption that there are 8 bags for another question. What I will try to do is I will try to fix one possibility and stick to that. If there are multiple possibilities possible, right? Because what will happen in that case is I'm going to get 1 mark or one question right out of the 2 questions that are there. If I change my answer for both the questions, if I stick to the same possibility for both the questions, there is a chance that that is indeed the wrong possibility, and I might end up losing marks for both the questions, right? So then that is a high risk, high reward kind of a game. Either you get both of them right or both of them wrong. I would be very happy getting one of them right and one of them wrong because I have no expectation from those questions. Okay, so hedge your positions well. In fact, you can have a look at the first few minutes of the other session that we did recently. Same thing, best of cat DIR. So you can have a look at that session, and there I have discussed this in some depth. Right. So the again, what we're going to do here today is very straightforward. What we are going to do is as I mentioned, we are going to do 4 sets. So what I will do is I will flash a set. For those of you who are interested in going ahead and solving that particular set, what you can do is you can take a screenshot or you can take a picture of the set that I will flash before you. And what you can do is you can start solving it. Till that point in time, I will just comment on the set a bit. I'll try to talk about what happened in that year's CAT, what exactly was the mindset when someone would have approached this particular set, where did this set stand among the other sets that were there in this particular slot, and so on. So we'll try to discuss those bits, and then we will start with the actual solution, right? So I'll just flash the first set and we'll see what happens. So the first set is this one. This is from CAT 2017 slot 2. I have called it security scan. A high security research lab requires the researchers to set a passkey sequence based on the scan of 5 fingers. And then these fingers are termed as thumb, index, middle, ring, and little. So TIMRL are the representations of the fingers. Then there is some variation that is allowed in terms of what the scan can look like. And there are some questions. I'll show you the questions as well, on the basis of which you have to figure out which one will work or how many possibilities will be there and so on. So I'll come back to this slide. You can take a screenshot or you can just search for this question. I'm sure you'll find this question online. Don't look at the answers. But the questions are as follows. So the lab has decided to allow a variation in the sequence of the scans of 5 fingers. So there was some case that was mentioned in the question. Here we have been told that there is some variation that is allowed. At most 2 scans out of 5 are out of place. So that is the first question. You have to figure out how many sequences of scans are required. Second question, again, variations are allowed, vary from the original sequence by 1 place for any of the fingers. So we'll talk about places and the codes that exist. Sequences that exist. Again, the question here talks about either 7 possibilities, 5 possibilities, 8 possibilities, or 13 possibilities. So we'll have a look at that. Third question, the questions become longer as you progress, right? The lab has now decided to require 6 scans in the past sequence where exactly 1 finger is scanned twice and the other fingers are scanned once, right? So 1 finger will be scanned twice, the other fingers are scanned once. So TIMTRL could be a possibility. That could be a code, a sequence, and then there are variations that are allowed, right? So that is the third question. Again, the fourth question is somewhat similar, right? So those of you who have an idea of this set, you can start solving it. I'll just comment on the whole look and feel of this section and this particular question before we go ahead and solve this. Right. So first of all, this was CAT 2017 slot 2. At that point in time, CAT used to be conducted in 2 slots. So whoever took it in the first slot would have seen some questions here and there, and then they would have formed a mindset that this is how I need to solve the second slot. Honestly, if you ask me, second slot was slightly easier, more concrete compared to the first slot, because if you look at the questions from the first slot, there were a lot of questions that were based on variances. So there was a question that was based on critical path, let's say, wherein you had to fulfill an order of burger, fries, and ice cream, if I remember correctly. And there are 2 employees who are there. You have to figure out when will the first order be fulfilled, the second order be fulfilled, for how much time will exactly one employee be free, and so on and so forth. Now that was a set which required you to take some leaps of faith. Of course, the questions were easy, at least 2 questions were easy, but it required you to take that leap of faith, wherein you are saying that, okay, my answer is 7 minutes, let's say, for example, but it can be 8 minutes as well. I might not have visualized some possibility. So there were a lot of possibilities there. Right. So that was one thing which made it slightly difficult, which made it slightly tricky. So that was one set that was there in the first slot. The next slot, the next set that I can talk about in that particular section was based on, say, the number of flights that are required to connect some cities that are there and so on. Again, you couldn't be sure of what exactly is going to be the answer. Again, one set was extremely difficult. There were instances given. So how many of these villages got 7 points? How many villages got 6 points? And so on and so forth. Right. So again, that kind of a set was there. There was a very calculation intensive set and so on. So that time there should be 8 sets, and the first slot had sets which did not really have concrete answers that you could be extremely confident about. Right. The second slot, on the other hand, had a lot of these questions wherein you had just one answer. So I have obviously not taken those sets because they were slightly easier than this one. But except one set which was based on arrangements in an airplane, and this one which was slightly on the trickier side, the other sets were more or less manageable. There was a set based on chess. There was a set based on, I think, vegetarians, non-vegetarians, and so on. So those kind of sets were there, which were mainstream normal sets. So out of 8 sets, 4, 5 sets could have easily been managed, and you could be certain about the answer if you had your basics in place. Right. So this was one of those sets which was slightly difficult because, as I mentioned earlier, there was uncertainty in terms of whether your answer will be right or not. You can say with confidence that my answer is 5, but is my answer 5 or not? And there was one trap that was in each of the questions, wherein some of the people who would have taken CAT in this slot would have definitely made some mistakes, and they would have got it wrong for sure. Because again, when I looked at this set for the first time, even I made a mistake in the first couple of questions at least. Till the time I realized that something, yeah. Okay, you found that set easy compared to this one. I don't know. If you're talking about the airline set, then I don't know. Honestly, that was an extremely complicated set. In fact, I don't have the courage to solve that set alive because it's too complicated, right? And it deserves to be left alone during the test. Anyway, doesn't matter, right? So this is what the set look like. So let's have a look at what exactly do we mean when we look at this set and what exactly can be the solution to the questions that we saw. Right. So there are 4 questions, as I mentioned. The first question, the first couple of questions have some common data, and the next couple of questions have something somewhat similar data, because now we have 6 scans that are possible. So first of all, let's look at what exactly is it that we are going for and what exactly is allowed. So we are saying that there is a passkey sequence required required to enter, that is based on the scan of the 5 fingers of their left, right? And those fingers have been named. So we have called those fingers thumb, index, middle, ring, little. So TIMRL. So that is what has been mentioned here. We have to say that when an employee first joins the lab, her fingers are scanned in order of her choice. And then when she wants to re-enter the facility, she has to scan the 5 fingers in the same sequence. So for example, if they are saying that, let's say initially the sequence in which the key was made was TIMRL, right? The original sequence was thumb, index finger, middle finger, ring finger, and little finger. TIMRL. Then TLMRI is also allowed. It's a very important word here also. Right? A lot of people get carried away and they say that, okay, this is allowed, and then they go for that as the answer. But of course, it is also allowed. That is the keyword here. So in this particular context, we are saying that TIMRL, right? So this is allowed. Of course, that was the initial sequence that was scanned by the machine. So if someone goes and presses TIMRL, then the machine will allow the person to go in. But there is some variation that is allowed. What is the variation that is allowed? They are saying that at most 2 scans are out of place. Now the first thing to understand here is, can there be exactly 1 scan out of place? So TIMRL we say, can only one thing be out of place? L, let's say, out of place. But then L will have to occupy someone else's place. Na? So there cannot be exactly one thing that is incorrect. Now for those of you who are well versed with the concept of derangement, you would have seen by now what exactly is it that we are talking about. Okay? So TIMRL is what we are looking at in this particular context. We are saying that exactly or at most 2 scans are out of place. Now at most 2 scans are out of place means that it's okay if there are no scans that are out of place. If everything is right, even then it's fine, it's not a problem. But at most 2 scans can be out of place, right? And then we have been told that okay, some TLMRI is allowed. So TMLRI is allowed. Now if you look at it, the first letter TLMRI, T is in the correct position, which is fine. I is not in the right position. M is not in the right position. R is in the right position. So TLMRI and TIMRL. Yeah, so TIMRL and TLMRI. Sorry. So if the initial sequence is TIMRL and the final sequence is TLMRI, then we can see that T is in the correct position, M is in the correct position, R is in the correct position. Okay, so 3 are in the correct position and we have basically swapped L and I. And this word is very important, swapped L and I. So at most 2 scans can be out of place, means that at most 1 pair can be swapped among themselves. That is what we have been told, right? Now in this particular case, if you are looking at the first question, the lab has decided to allow a variation in the sequence of scans of the 5 fingers so that at most 2 scans are out of place, which was mentioned in the question. How many different sequences of scans are allowed for any person's original scan, right? So how many different sequences of scans are allowed for any given person's original scan? Now this is an extremely easy question. Even if you have not understood anything, if you just know the basics of permutation and combination, you should have been fine in terms of this particular question, right? So in this particular question type, I know that the initial sequence is TIMRL. Okay, I know that at most 2 can be out of place. So let's say there are 0 out of place. Now 0 out of place basically means that we are just saying TIMRL is the input that we have provided and the machine will allow us to get it, or the security system will allow us to get it. Now the second thing is exactly 2 are out of place. So as we saw earlier, there cannot be a case wherein exactly one element is out of place, because if it is out of place, it has to occupy someone else's place. Okay, so exactly 2 are out of place. Now in how many ways can you select exactly 2 elements out of the 5 that are there, so that and change their order? That's it. I have to just select 2 elements. So for the benefit of those of you who are not very clear with this, let's say for example I take T and I and I swap their places. So ITMRL will be one case. Now let's say I take T and M and swap their places. So MITRL will be another way of putting in the sequence. Now let's say I take T and R and swap their places. So RIMTL will be another case. Then I say, let's say T and L get swapped. So LTM, LIMRT will be the next case. Now I have exhausted all those possibilities wherein T is getting swapped with something else. Now let's start with I. So I and M, let it get swapped, because I and T wala case we already figured out. So let I and M get swapped now. So we'll get TMIRL. I and R, let them get swapped. So you will get TRMIL. I and L, let's say they get swapped. So you will get TLMRI. Now I, we have exhausted all cases. Let's say we're talking about M and R. So TIRML is another possibility. M and L get swapped. So TILRM is another possibility. Now again, we have exhausted all possibilities that involve M. Now we are left with only one case, which is RL. So TIMLR. Now if you look at it, the original case, 0 out of place would have been valid, and you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cases. So in total, you would have had 11 cases. Now, of course, there are some people who are talking about it on the chat as well, wherein they are saying that we could have easily done 5C2, 5C3 as well, which is perfectly fine, right? So I did this for the benefit of those of you who are not able to visualize combinations or permutations rather. Okay. But in this case, what I had to do was I had to have exactly 2 out of place. Now I can select any 2 items and can just flip them around. So the whole question becomes, in how many ways can I select 2 objects out of 5? Or in how many ways can I select 3 objects out of 5? I want to keep exactly 3 constant, right? So 5C2 is the number of ways in which I can select 2 elements out of 5 and can interchange their positions, so that although the scan is incorrect, it is still allowed because of the special condition. But the original way in which I would be able to enter the sequence, thumb, index, middle, ring, little, would have been allowed as well. So TIMRL is obviously allowed, and in addition to that, there are 10 cases that are allowed. So in total, 11 cases are allowed. Now in this case, even if someone would have answered 5C2, right? 5C2 कर देते, तो भी problem हो जाता, because then you have not considered that original case that existed. And I know a lot of people who just entered 10 as the answer and came back, and then they realized that acha, the original case would have also been valid. We are not talking about only the wrong cases being allowed. We are talking about the original case being valid, and in addition to that, we have been given some allowance. Okay? Someone is asking why not 5C2 into 2 factorial. So my question is, why 2 factorial? Right? I am not saying that I will select 2 and then arrange those 2 in 2 different ways. No. I am selecting 2 elements and then swapping their orders. Right? I am not saying कि T और I को लेते हैं and then I will put TIMRL as one arrangement and ITMRL as another arrangement. No. If I put it again as TIMRL, then I have the original arrangement. Then it doesn't help me at all. I want those arrangements जहाँ पे I am swapping the 2 elements. Okay? That is by 5C2 and not 5C2 into 2 factorial. So that was the answer to the first one. Straightforward question. And I'm sure easily people could have answered this question. So let's go to the next one. Now the lab has decided to allow variations of the original sequence so that the input of the scanned sequence of 5 fingers is allowed to vary from the original sequence by 1 place for any of the fingers. So 1 place is what it becomes now. Earlier we had been told that at most 2 can be allowed to interchange positions, but here we have been told that the element can be allowed to move by 1 place for any of the fingers. Now the example has also been given so that it's easier for us. So TIMRL is the original sequence. ITRML is allowed, but LIMRT is not. Now what is happening here? T is going ahead by 1 place, I is getting switched by 1 place. Now we are saying that M is going ahead by 1 place, R is going behind by 1 place. So the impact on the first element is by 1 place, second element is by exactly 1 place, third element exactly 1 place, fourth element exactly 1 place, fifth element is 0 places. Now we have been told that it is allowed to be by 1 place, meaning that even if it is at the same position, it's fine. But whatever is getting changed has to move by 1 place. Now, as we saw in the previous question, if I am, a 5C2 into D2 works. Yeah, Jared, it works. But then D2 निकालने का जरूरत है ना? If I have 2 places and 2 objects, I can place them incorrectly in only 1. Right? So that was D2. Doesn't matter. So in this case, what we are doing is we have to take one element and move it either 1 place ahead or 1 place behind. But then the problem is I can't just move it and remove the other thing and put it somewhere else, right? Now that element also has to occupy some other place, no? How will that item occupy another place? Now if T went here, if I would have gone here, let's say for example, then M would have also had to move. And finally there would have been an issue because L kahan pe jaye? Right? So what we have to understand here is we are swapping 2 elements which are adjacent to each other. That's it. Right? So we are swapping 2 elements that are adjacent to each other, and that is basically how this will work. So I'll just erase all the ink on the slide and we'll try to do it again. So TIMRL was the original sequence. Now we can swap positions. Now how many swaps can we have? Exactly 1 swap or 1 pair ka swap? Exactly 2 pairs ka swap, as we saw in the condition that had been mentioned in the question. And there could be 0 swaps. Even if someone enters TIMRL, chalega na? They will be able to enter the room, right? So TIMRL. Now exactly 1 swap. Exactly 1 swap kaise hoga? Either T and I get swapped, so IT and others remain constant, MRL, or IM would get swapped, so TMIRL, or MR would get swapped, so TIRML, or RL would have got swapped, which is TIMLR. Okay, so these are the 4 cases जहाँ पे adjacent things are getting swapped and only one pair is allowed to get swapped. The second thing is exactly 2 swaps. अब exactly 2 swaps कहाँ पे होगा? As we saw earlier, T and I can get swapped. So IT, first 2 elements, and let's say third and fourth element. So IT, RML, the one that was given to us. That is possible. Or I will swap the first 2 and the last 2. So I will still have IT, M will be as it is, and LR will be the swap of the last. Now let's say I don't swap the first 2 at all. So first 2 के साथ what all combinations are possible? That's how we go ahead and solve this, right? So first 2 can be swapped. TI का IT हो जाएगा, and be along with that, उसके साथ MR can be swapped and L kept constant, or RL can be swapped and M kept constant. Now there is no other case जहाँ पे T and I are kept constant. Now we'll go to the next one. Let's say we have kept T as it is and I and M get swapped. So MI gets swapped. But we need one more pair to get swapped. And that leaves us with only one pair, which is RL, which will get swapped and become LR. Okay? So what we are saying here is, this is a possibility. 2, 3, 4, 5, 6, 7 possibilities exist with exactly one swap or exactly 2 swaps. And with 0 swaps, we are talking about the original arrangement that was there. So if someone would have entered this and would have just clicked login or whatever, the system would have allowed this person to enter inside. So we'll get a total of 7 cases wherein things are not the original, out of place, and 1 case which is the original. So in total, we are going to get 8 cases wherein the lab will allow the input. So the correct answer here is going to be option C, that is 8 cases. Okay. So that is basically how it works. Again, in this case, there was some chance that you would have messed up this bit. TIMRL ka original order could have been missed, and the paper setters are also extremely smart. They gave you one option 7. So some of you who might have missed out on this one, definitely they gave you 7 as one of the options, so that people end up making those kind of mistakes. Okay. But again, that's about it. Typically, these kind of things happen. Yeah. For doing this without permutation combination, we can use round robin kind of possibility to easily find the outcome. So Muralidharan, yes, correct, perfectly right. Again, I want all of you to start looking at it in terms of various sequences, right? So in this case, I am saying that 2 consecutive switch karna hai, right? There are 5. So this you can count on your fingers. So either this one, 1, 2 will get switched, or 2, 3, 3, 4, 4, 5. There are only 4 switches possible. You need not write down so many things. Then I am saying that exactly 2 need to be switched. So again, how did we go? Ye do, and then either these 2 or these 2. And either these 2 and these 2. That's it. So we need not write down all those things. I just wrote these things purely for all of you to understand how these cases look. Because I am sure there exist some people who will ask me this question, that if we are swapping and if we are using normal permutation and combination or a logic, what do we do with the original condition? Is the original condition a part of our answer? And if you look at all the conditions that are written here, none of these conditions is the same as the original condition. Okay? That is what I wanted to convince you, and that's why I wrote down these conditions. So, moral of the story, if you are not convinced during the test, make sure that you are writing down these cases and getting it done. Tamanna, you are right. You can use numbers as well. So instead of TIMRL, you can use 1, 2, 3, 4, 5. That is also perfectly fine way of looking at this question. Yes, you can use numbers. Okay. Let's go to the next one. Now again we have a theta question here in this particular case. So now the lab has decided to require 6 scans in the pass sequence, where exactly one finger is scanned twice, the others are scanned once. Now we have TIMTRL that has been given, right? Now the variation of the original sequence where at most 2 scans are out of place, as long as the finger originally scanned twice is scanned twice and all the other fingers are scanned once. So this entire thing is there to confuse you in a way, right? What they are saying is, because I have punched thumb twice in whatever sequence, even if I'm making an incorrect entry, I will have to punch thumb twice, right? Otherwise the system will not accept the response. But obviously, because we are swapping items among themselves, it is obvious that there will be 2 thumbs, 1 index, 1 middle, 1 ring, 1 letter in the final output. Okay, so that is what we are looking at in this particular case. Now in this case, what we are saying is variation of the original sequence where at most 2 scans are out of place. Now we have not been said that they are talking about one place that is interchanged. we need to have at most two scans that are out of place. At most two scans ka what was the interpretation? Exactly 0 out of place or exactly 2 out of place. Okay. Now in this particular case, all right. So in this particular case, exactly 0 out of place, there was only one case, right? So TIM, TRL, we pakad ke chalte hain. TIM, TRL would have been the one that you would have entered and got. Right? Now exactly 2 out of place. We had seen it earlier. Exactly 2 out of place mein kya karna hai? We have to select 2 out of 6, which we can do in 6 C2 ways. So 15 such cases are possible. So my answer becomes 1 plus 15, that is 16. Yeah, is my answer 16? Let's see what people say. Some of them have mentioned already. One I got 13, one I have got 15. Yeah. So if you are looking at what has been given here, 16 is what I have written in this particular context. But there is one small thing that some of you would have missed. And exam ke time, if you look at it, it's very common for people to miss out on these particular things. Right? So 16 यहाँ पे 15 selections are possible. But what are those selections? So I am looking at TIMTRL. If I'm looking at yes, Palak correct, Arjun yes, Tamanna yes. So we are talking about repetition here. So let's say for example, I am selecting T and I. Right now, I am not just selecting T and I am also saying that uske position interchange karenge. So my answer becomes ITMTRL. This is a possibility because MTRL are at their correct positions, but T and I have swapped. Let's say T and M ko maine swap kar diya. I remains where it is. So we'll get MITTRL. Again a possibility which exists. Let's say I swap T and T now. Now what am I going to get? TIMTRL. Now this and this are the same thing, no? Right? So one case wherein I am interchanging these two T's is going to be the exact same case as is the original case. So the 15 that I have found here includes that one case wherein we are swapping two T's. So if we are swapping two objects which are the same, the output will remain the same. Na? So we have to adjust for that one particular output. So my answer is going to be 1 plus 15 minus 1, which is right. So don't go ahead and simply mark 16 as your answer because 6C2 plus 1 apna kaam ho gaya kar, right? Be a bit careful. And when I said these are the kind of questions wherein you might end up making mistakes which will hurt your expectations, right? You are going to get the same marks depending on what you have answered, right? But then what would have happened in this particular case is you would have messed up your answer purely because you had not written down the cases. So if you have a lot of time on hand, you are expected to solve one or two sets. You have figured out that these are the two easiest sets. If you are confused, write down those cases and see what happens. Okay? Write down 4 or 5 cases. Utne mein you will get the confidence to mark the answer. But if you are not confident enough, if you have that doubt in your mind, ki repetition hai, how to deal with repetition, some of you will try to divide it by 2 factorial. Hoga nahi hoga, you don't know, right? So make sure that you are not doing all those kind of things. You can write down the cases. 15 cases likhne mein bahut time nahi lagega. Your previous question was an indicator that there are 7 or 8 cases that are there, right? So don't bother about the number of cases that you might have to write. Make sure that you are writing down the cases so that you are on the safer side. Okay. Last question of the set. Again, similar. What we are saying in this case is the lab now decides decided to require 6 scans in the pass sequence where exactly one finger is scanned twice and the other fingers are scanned once. TIMTRL is the same case that we have been told to us, which have been told. Variation of the original sequence of 6 inputs so that the input in the form of scanned sequence is allowed to vary from the original sequence by one place. Now again we are talking about one place here. Okay? Now one place के बारे में बात कर रहे हैं. We are talking about adjacent things that can go wrong. So in this particular case, again we'll try to write down everything. So TIMTRL, not write down all cases. I'll just talk about the cases that are there. You can write down and see whatever I'm saying makes sense or not. If not, you can put it in the comment section below and we will try to see what happens. Okay? All right. Just one question ka answer plus 5C1 repeated letter. Okay? So in this case, let's see what happens. Again, we are allowing swaps. So one thing is 0 swaps. Okay? One thing is exactly one pair swaps places. Then exactly 2 pairs swap places, exactly 3 pairs swap places because of 6 things here. So zero swaps will be one case, which is the original case. So TIM, TRL डाल दो, get into the laboratory and end of the story. Next में one pair is getting swapped. So again, as I mentioned earlier, we have to have adjacent things because one place के साथ we can swap. So TI or TM or TT or TR or TL. अब वैसे नहीं होगा in this case. What we are saying is adjacent swaps. So we are looking at adjacent things that are there. So TI or I and M will get swapped, or M and T will get swapped, or T and R will get swapped, or R and L will get swapped, and the remaining elements will remain the same. So TI swap होता है, so IT MTRL. IM swap होता है, so TMI TRL. MT swap होता है, TI TMRL. RT swap होता है, TIM RTL, and the last one TIMTLR. So all these are the cases that are. So one pair अगर swap करता है, then we are talking about 5 cases, right? TI, IM, MT, TR, RL. 2 pairs swapped. So again, we can look at it in a systematic manner. Let's say we are talking about TI. फिर क्या होगा? MT can get swapped, or TR can get swapped, or RL can get swapped, right? So we'll have 3 cases for TI. Now let's say IM is one that is there. I need one more pair to swap. So either TR will be the one that will get swapped, or RL will be the one that gets swapped. I'm not talking about backwards. I'm just talking about this. Now let's say the next case is MT is one pair. Now MT and TI we can't do because TI, MT were already accounted. So we have to go forwards. MT के साथ में there is only one possibility that exists, which is RL. Okay? So this is what we are saying. And 3 pairs swap में TI will get swapped, MT will get swapped, and RL will get swapped. So in total, if you are looking at it, how many cases will you get? 5 plus 1, 6 plus 6, 12 plus 1, 13. So in total, you will have 13 possible sequences for this question. Yeah. So a lot of you got it right. I hope it is clear. So the set is very easy. It's easy to read, more or less manageable to understand. The problem is the questions, right? Each question can have multiple possibilities. You have to figure out how many possibilities exist. The question is not what, the question is how many, and that is a problem. Okay? If the question would have been what, which of the following is a required sequence, it would have made your life much easier. So if sequence dekhte, you would have matched the condition and figured it out, right? Just because the question talks about it in terms of how many sequences are possible, that is what makes it difficult. ठीक है? Different sequences पूछा हुआ है. Yeah. How many different sequences of scans are allowed? So how many scans are allowed? That is the question, na? So original sequence LR, LT, IM, it's the same thing. So okay, so LR, LT, IM. As long as we don't have adjacent things that are the same, we are not supposed to worry about it. So which scan is allowed? Is this scan allowed? It is allowed, right? Are the others allowed? Yes, they are allowed. So basically, there are 13 things that are allowed. Fine. So we'll go to the next one. Right. So this is again an interesting question. Mathematical reasoning. So first one was slightly convoluted mathematical reasoning. Some element of derangement, some element of permutations and combinations was involved. This is purely math, right? So when we say mathematical reasoning has been appearing at the CAT. Okay. So for the first case, Rishi is asking what should be the priority for this kind of a question, right? So again, my point here is you have to make sure that you know what your expected value is. Okay? So for the first set, my expected value would have been 2 correct, 2 wrong. If I would have got 2 right, 2 wrong, I would have been very happy with the outcome. So if I'm going to gain a total of 4 marks, I need to understand how many minutes am I wasting on the section. Given the context, CAT 2017, DI section was of 1 hour. So 1 hour ka agar section hai, I am expected to gain somewhere around 30-32 marks. To gain 4 marks, I am going to invest say 8 to 10 minutes. So that is basically my objective. If I am getting one set which is sure shot, which everybody would have done in that particular slot, which could be that vegetarian, non-vegetarian wala set, which was an easy set, right? Or the chess set, which some of you might have done. Agar ye wale sets mere paas already pending hai, then I will not get into that set. But if I am done with all the sets that I am absolutely certain about, only then will I jump into this set. But I will have it at the back of my mind. This is like an RC question. Right? A lot of you will know that, okay, RC question के अंदर answer mark कर भी दिया तो भी how confident are you that it will be right? Right? So same thing is was the context in the previous. Okay? I will not do it in the first go because I don't know what to expect. Right? I can't say that 10 minutes हो गया, but I am not sure how many marks am I going to get. I would rather do something which gives me certainty of getting some marks than doing this. Fine. Okay, now let's look at the next one. We are talking about CAT 2021 slot 3 impurity detection. So this year the format changed by a bit. So CAT 2020 was the first CAT in the COVID era, right? So there we had 3 slots, but then the number of questions was 76. This year the number of questions came down to 66. CAT 21, the same was repeated in CAT 22, and we had 24 questions, or rather 20 questions from DILR. Okay? The only problem was 20 questions in DILR were in the form of 6 plus 4 plus 6 plus 4. So 2 sets of 6 questions each and 2 sets of 4 questions. So this was a 4 question wala set that was. Okay? So if you look at the set, again I will try to explain the set first, and then you can solve simultaneously, and then we will go ahead and solve it, right? The last set was a low accuracy set. Yes. If the questions make the life easier, then it's not CAT. Yeah, correct. And if the options are the ones that you are getting, then again you have to cross check, because there could be some paper setters who are safest, okay? Which is fine. I consider myself one of those, so no harm. Okay? But we are talking about this question now. So question fairly straightforward, mathematical reasoning hai. I am sure some of you are worried about mathematical reasoning questions, क्योंकि उसमें maths आ जाता है. If you are especially not good at quant, you will hate looking at these kind of sets. Weighted average दे दिया है, 80% है, 20% है, and so on. There is some logic involved, some calculation involved. You might not want to go ahead and hit this set. But honestly speaking, this was one of the easiest sets of the entire test, right? So in this particular set, if you look at it, you have to understand what exactly is happening in terms of the mixture. There are 2 possibilities that exist. One, the liquid in any bottle can be 100% pure in terms of content, or it can have certain amount of impurity, which is denoted by an I. Visually, it's not possible to distinguish between P and I. There is a testing device which detects impurity as long as the percentage of impurity is 10% or more. Very important, and obviously the only point in the question that is there, 10% or more. So if it were more than 10% or 10%, it would have detected ki impurity hai. Okay? So what we have been told is, we have been given an example. There is a bottle 1 which contains only P, and there is a bottle 2 which contains 80% P and 20% I. Right? Now if content from bottle 1 is tested, because there is 20% impurity, it will be found that it contains only P. Right? So bottle 1 contains only P and bottle 2 contains 80% purity. So we have been told that 1 के अंदर only P है, which means that 100% purity वाला solution. Now 10% या उससे ज़्यादा impurity है ही नहीं. So bottle 1 will say that bottle 1 contains only P. Contents of bottle 2, if they are tested, they will reveal that it contains some amount of I. It will not tell you what percentage of impurity. It will just tell you that the mixture is impure. Why? Because it contains 10% or more of impurity, because it has 20%. Okay. Now if bottle 10 ml of bottle 1 is mixed with 20 ml of bottle 2, okay? 10 ml of bottle 1 is mixed with 20 ml of bottle 2, what will happen? 10 ml के अंदर तो 10 ml of pure solution होगा, 20 ml of bottle 2 है. Now I am saying 20 ml of bottle 2, that basically means that you will have 20% impurities, right? So 16 ml of solution, pure solution, and 4 ml of impurities. Yeah. Now if you mix both of them, you will have 30 ml ka solution. And out of 30 ml, what will be the level of impurities? 4 ml will be impurities. Now 4 out of 30 is impurity. 10% के ऊपर है. Yes. So then the mixture will be said to be impure on the basis of the test. Okay? Second condition. If 10 ml of bottle 1 का content is mixed with 5 ml का content from bottle 2. अभी 5 ml में 20% is impurity. So 4 ml is the pure solution and 1 ml is the impurity. Now in this case, we will have 1 ml of impurity in terms of 15 ml of the solution. So 1 out of 15 if I am saying, then the answer is not going to be equal to or more than 10%. कैसे पता चला? I need not calculate on my 15. 15 का 10% कितना है? 10% of 15 is 1.5. 1.5 से तो कम ही है ना मेरा numerator. Because my numerator is less than 1.5, it is 1 ml. I can say with certainty that the impurity here is going to be less than 10%, in which case the test will not detect any impurity. Okay? That is what we are trying to say in this particular context. Right? So 16 plus 4, that will be the split, as I mentioned, Palak. So this is what it looks like. Now beyond this, कुछ भी नहीं दिया हुआ है. So now what am I supposed to do in life? I'm supposed to look at the questions. So let's look at the questions. Let's try to see if the questions are helpful or not. So 5 ml of content from bottle A is mixed with 5 ml of content from bottle B. Now, because there was nothing in the question as such, the data in the question as such, I know that my entire game is going to be interpreting the questions that are there, which is obvious, which makes it obvious that the questions will be in the form of ifs, right? So there will be questions that will have an if component involved. If it is known that bottle A contains only P, in minimum how many tests, or if all of them contain P, kuch to batayenge. In this case, what is the minimum number of tests possibility again? What is the minimum number of tests possibility again? Right? So these questions are based on possibilities, which makes it slightly, again, as I mentioned, you might or might not be confident when you're answering the question. Okay, so it makes it slightly a low accuracy wala set, but then again it's fine. We know that we don't have anything to do in terms of the question. We only have to look at the or the original data that has been given to us. We only have to look at the questions that are. So let's do that. So in this case, we have been told that 5 ml of content from bottle A is mixed with 5 ml of content from bottle B. The resultant mixture, when tested, detects the presence of an impurity. If it is known that bottle A contains only P, what best can be concluded about the volume of impurity in bottle B? Now bottle A contains only P, which means that 5 ml of solution bottle A का जो है वो entirely pure. Now you have bottle B. Now on the basis of the mixture, जो 10 ml का mixture बन रहा है, 5 ml from bottle A and 5 ml from bottle B, whatever 10 ml of mixture is being formed, we know for sure that this has been detected as impure, or it has detected the presence of an impurity. When will the machine detect the presence of an impurity? Right, the device will detect impurity when the percentage of impurity is greater than or equal to 10%, or is greater than or equal to 10. So in this case, we are saying that 10 ml may say at least 10% is impurity. So I know that 1 ml or more of impurity has crept in from the 5 ml of bottle B ka content that has been mixed with bottle A ka content. Okay? Now 1 ml out of 5 ml, 1 ml or more out of 5 ml has been mixed with A. So what can we say in this case? Bottle कितने capacity का है? 50 ml का है. We have been told about volume of I in bottle B, not volume of I in the mixture. That's very important here. A lot of people might think of volume of I in the bottle in the mixture. They can happily mark 1 ml and go ahead and right. In this case, the paper setters were slightly kind. I would have maybe set an option which said 1 ml or more, and then people might have marked that as the answer, right? So in this case, I am saying that 1 ml out of 5 ml is present. I have to talk about bottle B. Now 1 ml out of 5 ml or more, in terms of 50 ml, what will happen? It will basically be 10 ml or more, right? Out of 50 ml. So more than 20%, 20% or more than 20% has to be the impurity in bottle B. So in this case, 10 ml or more is our answer, option B. Right? Now again, one more way of looking at the question, same thing, but slightly different way of talking about things. A के अंदर 0% impurity, B के अंदर 20% impurity. I'm just talking about a number, 20% impurity. Now when you mix both of these in the same volume, these 20% is going to get split into two parts, na? So it will become 10% here, 10% here. Effectively, the mixture is 10% impure, which makes it detectable. If I would have told you that B के अंदर 40% impurity, resultant mixture, if A and B are of the same amount, or same amount has been extracted from bottle A and bottle B, 40% is the impurity in bottle B, 0% is the impurity in bottle A. When you club both of them, you will get 20% impurity in the mixture, 40 divided by 2. Because the impurity would have been split equally. Okay? Joydeep, it said 5 ml was taken. Yeah, 5 ml was taken. So 5 ml के अंदर 1 ml was the impurity. But the question is, what best can be concluded about the volume of I in bottle B? Bottle B में कितना है? Each of the bottles mentioned in this question contain 50 ml. 50 ml में से 5 ml you have taken. But I'm not talking about what has been taken. I'm talking about bottle. ठीक है? So bottle के अंदर का impurity would have been 10 ml or more out of the 50 ml level. Fine. We are talking about bottle, volume of I in bottle. Okay? And again, weighted average. For those of you who are even more into mathematical reasoning, 0 here, something here, 1:1 का ratio है, 10% पे detect होता है. If this gap is 10, this gap will also be 10. So 20% of the solution was impure. So even that is one thing that we can think of. All right, let's look at the next one. There are 4 bottles. Each bottle is known to contain only P or only I. Right. So each bottle is known to contain only P or only I. They will be considered to be collectively ready for dispatch if all of them contain only P. In minimum, how many tests is it possible to ascertain whether these 4 bottles are collectively ready for dispatch? So even if there is one bottle which has an impurity, it will not be collectively ready for dispatch. Okay? So let's write down those cases just to visualize it well. So we are saying that, let's say we have all bottles containing P. So everything is pure in this case. There is exactly one bottle with impurity. There are exactly 2 bottles with impurity. There are exactly 3 bottles with an impurity, and all 4 bottles have an impurity. So there are these 5 cases that exist. All pure, exactly 3 pure, exactly 2 pure, exactly 1 pure, none pure. So those are the only cases that exist. Now think about it. When can we say that the mixture or all these bottles are collectively ready for dispatch? Right? Only when all of them contain P. So let's say, for example, what happens in this case? So in this case, let's say I take the same volume from all bottles and I mix them. What will happen in this case? The mixture will be deemed to be pure because the resultant impurity is less than or equal to 10%. It's less than 10%. So बोलेगा कि mixture pure है करके, right? And we know that it is collectively ready for dispatch. Now let's see if there is an impurity in one of the bottles, does it creep into our discussion or not, right? So that is what we are trying to say. So in this case, what will happen? Each bottle is known to contain only P or I and collectively ready for dispatch if all of them contain only P. In minimum, how many tests will we be able to figure out whether these bottles are collectively ready for dispatch? So again, in this case, let's say I have 4 bottles here, right? 2 bottles have a P in it and 3 bottles are pure in terms of the mixture that are there, and there is 1 bottle that has an impurity. Okay? So in terms of the question that we have here, if I take equal proportion from each bottle, let's say for example, so if I take equal proportion from each bottle in this particular case, then what will happen? I will have 1 bottle that will have impurity, but this has 100% impurity. As we saw in the previous case, 100% impurity agar hai, it will get distributed equally among the 4 bottles that are there. So then the resultant mixture, what will happen in the resultant mixture? It will have 100% divided by 4, that is 25% impurity. And in that case, if I'm talking about 25% impurity, then we will have the mixture that will show us that it is impure in this particular case. Okay? So the mixture will show us impurity, and because it is showing us impurity, it will not be collectively ready for dispatch in this particular case. Okay? So 25% impurity. In this case, 2 bottles have impurity or 100% impurity. 2 bottles are 100% pure. You have 100 plus 100, 200 divided by 4. It will tell you 50% impurity, which is again represented. So again, it will tell you collectively not ready for dispatch, which is fine. The next one, we are talking about PIII. In this case, again, we are saying that because there is 300% or 300% impurity, divided by 4 will give us 75% impurity. And यहाँ पे because 100% impurity, again we will not be able to talk about the solution in this particular case. Okay? So यहाँ पे the machine will tell us 100% impurity. And that is basically what we need to see in this particular context. If I take equal volume from each of these bottles, and then I say that we will try to see which or how many tests together it is we are able to ascertain whether the mixture can be sent or not. Yeah. So in this case, how many tests will it be possible to ascertain? I think the options are slightly off here. We will be able to ascertain in one test itself. In this case, because if we are planning to look at the solution from each of these bottles, mix these 4 solutions in the same proportion, and then try to figure out as to what exactly is going to be the answer, then in this case, so these options are for some other questions, 7, 5, 8, 13. So ignore the options. The answer here is going to be 1 in this case, because I'm taking equal quantity from each of these bottles, mixing it, and even if there is one bottle that is showing some sign of impurity, it will tell us that the mixture is impure in nature. Okay? And that is why in this case, forget about the options. The correct answer here is option, or the correct answer here is 1. In one test, we'll be able to figure out whether the mixture or the bottles are collectively ready for dispatch or not. There are just 5 possibilities, Arjun. So those are the exact 5 possibilities that exist. Okay? So ignore 7, 5, 8, 30. I think that was from the previous question that got corrected. Fine. Next question. There are 4 bottles. It is known that 3 of these bottles contain only P, while the remaining bottle contains 80% P and 20% I. Right? So in this case, 80% P, 20% I is present in the 4th bottle. Now we have to figure out which bottle contains some amount of impurity. Now in this case, this 20% is a good indicator. Now we had seen it in the first question as well. Whenever we are mixing quantities from 2 bottles in the same amount, I will be able to figure out whether there is an impurity or not only if the spread of the impurity is greater than or equal to 10%. Right? So spread का मतलब ये है 20% अगर है. Now let's say I mix the same quantity from 4 bottles. These 20% are going to be distributed evenly. So 20 by 4 will give us 5% impurity in the solution. Now that is not good enough for me to detect impurity, because impurity detect करने के लिए the concentration has to be at least 10%. Right? What if I'm mixing equal quantities from 3 bottles? 20 divided by 3 हो जाएगा, which is 6.66%. Now again in this case, I am not sure whether the mixture is impure or not, because the machine will tell us that it is fine, but there is impurity that exists. तो मेरे को नहीं पता. But if I mix 2 bottles and one of them is impure, let's say, then in that case what will happen is this 20% is going to be distributed evenly across those 2 bottles, and it will tell us that 10% of the mixture is impure. And if 10% of the mixture is impure, then it will tell me that okay, there is some impurity in this particular solution. अभी आगे जाके पता चलेगा कि वो impurity कहाँ से आया है, but it will tell me that there is some impurity in the solution. Now, why am I taking equal volumes of multiple bottles at a time? Because I don't know which bottle is impure in nature. Now, if I don't know which bottle is impure in nature, I have to make sure that there is equal representation across bottles. नहीं तो I will not know why a particular mixture has given us impurity, right? And that's why we mix the same amount from multiple bottles and then try to minimize our outcomes and figure out what is the most optimum. नहीं तो क्या करते हैं हम लोग? Think about it. Let's say I take the first bottle, I do the test, pure है. Second bottle, pure है. Third bottle, pure है. Fourth bottle is impure. Now I have taken 4 or 3 tests to figure out which 3 are pure and which one is impure. If I am taking one bottle at a time, so 3 can be one of the answers. Worst case क्या होगा? Pigeonhole principle, right? Your first bottle is pure, second is pure, third is pure. I know that the fourth is impure because exactly 3 में P है करके पता है आपने. Right? It is known that 3 of the bottles contain only. So 3 is a possibility that exists. But we want to optimize minimum number of tests. So we will use this knowledge that these 20% are going to be spread evenly across 2 cases, and that's why we will see what happens. So let's say I'm talking about A, B, C, D. 4 bottles है अपने पास. Let's say okay? I don't know where the impurity is. Let's say the impurity is present in D again. I don't know, right? What I will do in this case is I will club A and B and see what happens. So A and B तो दोनों pure है. So what is going to be the result that I'm going to get? I am going to be told that A and B ka solution is pure. Because of this, I know for sure that A and B are not the 2 bottles where the impurity exists. I also know that there is exactly one bottle जहाँ पे impurity exists. So what will I do? I will test C. C को test करेंगे. अगर C में impurity आता है, if there is a trace of impurity in C, then C will be the bottle wherein there is some amount of impurity. If there is no trace impurity in C, then I know for sure that D is the bottle जहाँ पे impurity. Right? So this is the first case wherein the first 2 bottles that we selected had no impurity among them. Now let's say, for example, there is a parallel universe wherein again A, B, C, D are there. Again D is the one with impurity. I chose C and D in the first case. Now because I have chosen C and D in the first case, because 20% impurity gets evenly spread across 2 bottles, I am going to get 10% impurity in each of C and D. I know for sure that 10% impurity hai, test will be positive. Now, because my test has already been positive, I know that A and B are definitely pure. So I need not test A and B. So what I will do in this case is, I will look at C and D both, and then I will look at one of them. Now let's say I test C, and when I test C, I don't see any impurity. I know for sure that D was the one that was contributing impurity. On the other hand, if let's say for example, I am taking D, and then wahan pe if I am getting impurity, I know that D is the one that has impurity. Yeah. The one of the comments is, what if the first bottle is impure, right? What if the first bottle is impure? It's the same thing. Then it becomes a game of luck. Can I be certain? Your premise is dependent on the fact that there is a chance that A might be the first bottle, in which case एक ही chance में मेरा आंसर आ जाता है. But the question asks you definitely identify. Definitely identify basically means that definitely identify basically means that you have to be certain across scenarios. Even in the worst possible scenario, wherein the fourth bottle is impure, you have to be definitely sure that the fourth bottle is your answer. Okay? That is why we are talking about the worst possible outcomes. So here we are not talking about what is the minimum number of tests which might give you the correct answer. Then one, right? In fact, without testing also you can say, acha, one answer, let's guess kar. Right? But let's say for example, one test mein answer aa jata hai because the first bottle that you chose, that was your answer. But then we can't expect to be lucky na, every time. Yeah. So always go for the worst possible case. This is classic pigeonhole principle enough. Right? 3 bottles we can't take, Komal, because then the 20% impurity gets distributed evenly across 3 bottles, leading to a 6.66 impurity in the mixture. So the mixture will tell you that it's pure, but there might be one bottle which is impure in nature. Okay? That's why we can't take 3 at a time. Let's go to the last one. There are 4 bottles. It is known that either 1 or 2 of these bottles contains only P, while the remaining ones contain 85% P and 15% I. Right? So 1 or 2 of these bottles contain only P. So let's say there is one bottle that is there, and the other bottles contain 15% I, 15% I, 15% I. There's another case wherein 2 bottles are absolutely pure, and the remaining 2 bottles have 15% impurities each. Now we can just talk about impurities. We need not talk about 85%. We can just talk about impurity. And as we know, the impurity gets nicely distributed across. So that should help. Right? So in this particular case, either this is the situation or this is the situation. How many tests are required to ascertain the exact number of bottles? Now, exact number of bottles does not mean bottle number 1, bottle number 2, bottle number 3, bottle number 4. It basically means one bottle impure hai ki two bottle, one bottle entirely pure hai or 2 bottles entirely pure hai. That is the question that we are asking in this case. Okay? So don't think about it in that manner that exact number of bottles, मतलब bottle का number क्या हुआ है, right? If you look at the question, there nowhere has been mentioned that the bottles have been numbered. Exam के pressure में you might feel कि exact number of bottles मतलब bottle का number, right? It's not a straight translation into Hindi. Number of bottles means how many bottles. So in this case, if I'm talking about the entire impurity, it's 45%. In this case, the entire impurity is 30%. Again, entire impurity is cumulative percentage, right? Now, if I mix everything in the same proportion, this 45% is going to be distributed evenly, which means that my overall impurity is going to be greater than or equal to 10%. In this case, 30% is getting distributed evenly, so my overall impurity is going to be less than or equal to 10%. So in this case, if I mix everything in the same proportion, I am going to get my answer as impure, and in this case, I am going to get my answer as pure. So if I take equal parts from each bottles and test it, अगर test में impurity आता है, I know that 3 of them are impure, right? And if I take equal quantities from each bottle and then I club them and do the test, I am going to get pure as my answer. So pure answer अगर आता है, तो exactly 2 have impurities. Impure answer आता है, तो exactly 3 have impurities. So we can be sure on the basis of just one test how many bottles will have pure solutions. Okay? So how many bottles contain only P? That is the question. Which numbered bottle nahi bola hoga. So be very careful when you think. Okay? So in this particular case, the answer is going to be 1. Exactly 1 iteration, 1 test is enough to figure out the exact number of bottles containing. Fine. So in these situations, be very careful as to what the question is trying to ask. All right, we'll go to the next one. Quickly, we'll move on to the next question. Yes. So in this question, again, there is going to be a lot of trial and error that will be involved in this question. So you have to be absolutely certain about what we are doing. And again, this is a painful question, honestly speaking, right? So again, one of those questions wherein you may or may not be certain about your answers. So 25 beads are there that need to be arranged in a grid, in a 5 by 5 grid, and each grid in this cell must contain exactly one bead, and so on and so on. Right. So this is basically what we have here. So again, we have to figure out the various cases that are there. Yeah. Why not 2? Because we have been asked the minimum number of iterations required, right? So minimum number के अंदर अगर एक में आंसर आ रहा है, for sure, irrespective of whichever case is true, why should we go for the second case? ठीक है? Sure. Now let's look at this beads wala question. So in this case, 25 colored beads are to be arranged, and again there are certain situations that have been given to us. This set is easier than the previous one. Yes, it is easier than the previous one, but there are a couple of reasons why I took this set. One is because you will have to draw that 5 by 5 grid in each and every case. If I would have taken the chess wala set, you would have had to draw that 8 by 8 grid for each answer. Now drawing that 5 by 5 grid, 8 by 8 grid is something that a lot of people might have resistance to, and they might start thinking randomly what the answer could be, right? So that is one reason. The second reason is, again, there is a possibility that you might miss out on certain cases, and you might get 1 or 2 answers wrong. So that was the reason why I took this set. Not because it is difficult, because it is irritating, right? It's fairly irritating, honestly speaking. So that's why I took this. So यहाँ पे basically there are 3 rules that have been given to us. 2 adjacent beads along the same row or column are always of different colors. There are just 3 colors that are there: red, blue, or green. So that makes our life slightly easier. There is at least 1 green bead between any 2 blue beads along the same row or column. So if there is a blue bead here and a blue bead here, there has to be at least 1 green bead between 2 blue beads in a row or a column. Right? That is what we have. There is at least 1 blue and at least 1 green bead between any 2 red beads along the same row or column. Okay? So if there are 2 red beads, then there has to be at least 2 beads between these 2, and if there are 2, one of them has to be blue, one of them has to be green. Right? So itna hi question diya hua hai. Again, there are tons of possibilities that exist, so we know what is there in terms of the questions. The total number of possible configurations is what is the maximum possible number of red beads, minimum number of blue beads, 2 red beads have been placed here and there. Okay? So that makes it slightly tricky. It's not exactly a very easy question to answer, right? So it's slightly painful, to be honest. Okay. So in this case, let's have a look at what exactly is going to happen in terms of the solutions. Yeah. Okay. So this makes it slightly difficult. So I have tried to draw something here and keep it ready so that I don't have to draw another grid. So that's what I have done here. Total number of possible combinations using beads of only 2 colors. Okay. Total number of conditions that are possible by using beads of only 2 colors. So what will we do in this particular? Right. So if we are looking at these kind of cases that exist, we will have to figure out as to what exactly can be the case. Yeah. So we have the data here in front of us. 2 adjacent beads are always of different colors. That is what we know in this particular context. We know that there is at least 1 green bead between any 2 blue beads. So that is what we know. And at least 1 blue and 1 green bead between 2 red beads. So if I have 2 red beads, then there will be at least 1 blue and 1 green bead that are there. Now we are supposed to use only 2 colors. Now because we are supposed to use only 2 colors, if I'm using red, blue and green, then it's a problem, right? So I have to eliminate 1 color. Now if I eliminate 1 color entirely and I have multiple reds and greens, let's say for example, मैं blue को उड़ा देता हूँ, मेरे को blue नहीं चाहिए. I only go for red and green. Now if I'm going for red and green, then what will happen? If I have a green here, I will have a red here, which means that I will have a green here, I will have a red here. But between 2 red beads, there has to be at least 1 blue and at least 1 green. Na? So blue के लिए जगह ही नहीं बचता in this particular case. So red and green can't be used. Similarly, we can't use red and blue because there is going to be a problem. if I'm using red and blue, let's say I put a blue here, I have to put a red here because adjacent row, adjacent beads cannot be of the same color. Again, I'm putting a B here. But the problem is there is at least one green bead between any two blue beads. So this doesn't work. Okay. So in this case, we are not going for red and green or red and blue. So we are going for green and now green blue में क्या करेंगे? Let's say I start with a green. This one has to be a blue. This one has to be a green. Has to be a blue. Has to be a green. Now if this is green, this becomes blue because adjacent in a column should also not be of the same color. So again, you are getting it. What we are doing? B G B G B. Again, you will have G B G B G B and so on. Okay. Now this will help us crack the set, and this is in fact a good arrangement. Why? Because two adjacent beads are not the same color. Yes. There is at least one green bead between any two blue beads. So दो blue bead के बीच में green bead है, दो blue beads के बीच में एक green bead है, right? So any two successive blue beads, if you look at them, there will be at least one green bead between these two. Fine, and that is why this is a valid arrangement. So one arrangement is this. Another arrangement. Why did we start with green? We could have as well started with blue. So if I would have started with a blue, green, blue, green, blue, and so on, again I can see that this will also hold true. Every successive pair of blue beads in a row or a column are separated by a green bead. Makes sense. There is no red, so we don't have to worry about that case at all. Adjacent beads are not of the same color. Great. So either I start with a B and write it as B, G, B, G, B, and next one becomes G, B, G, B, G, or I start with a G, G, B, G, B, G, B, G, B, G, and so on. Right? So depending on the first element that we are putting, there will be two cases that will be possible. So the correct answer here is going to be 2. Yeah. So Zoom guy, Tanushri, Manas, Aditya, all of you are right. Yeah. And Anshu, yes, these are again low accuracy sets that I have chosen today. The last set is the one which is slightly manageable, but the others that I have chosen today are all low accuracy sets, wherein there will be multiple possibilities that will exist. And even if you mark the answer, you might not really be supremely confident that your answer is indeed right. Okay. So that is why these sets have been chosen. Okay. Now we have the next question that is there. Yeah. So let's look at the next question that exists. Okay. So the next question tells us that what is the or asks us rather what is the maximum possible number of red beads that can appear in any configuration. Okay, that is what has been given to us. So in this context, we have to again do a bit of trial and error and figure out red के बारे में what is it that we know. If there are multiple red beads in a row or a column, then there has to be at least two beads that separate them. Right? So let's say, for example, red is present here. Then the next red can either be present here or it can be present here, but not both. So एक row में there can be a maximum of 2 R's. Okay? In one row, there can be a maximum of 2 R's that are present. There cannot be 3 R's in a row. There are 5 rows in total. So what is the maximum number of R's that I can accommodate into this mix? Theoretically, practically chhodo. Theoretically, if I'm talking about it, I'm talking about 10 is the maximum number of red beads that you can put, because there can be at most 2 R's in one row and there are 5 rows. So at most 10 beads is what we say. Now if it is practical or not, we can test. So let's say मैंने यहाँ पे R रख दिया, यहाँ पे R लिख. Second वाले में I am putting R here, I am putting R here. Now third वाले में I can't put an R here, I can't put an R here, I can't put an R here, I can't put an R here. So R is here. Fourth row, I can put an R here. यहाँ पे R नहीं आ सकता because I need two R's to be separated by 2. Here you can't have an R. Here you can have an R. Here you can't have an R. Again you can have an R here. You can have an R. So in this case, we are going to get the answer as 9. Now 10 is not possible purely because we also have to accommodate the columns, na? Right? So we have to accommodate the columns as well. Whatever other thing you do, you will still not be able to accommodate all R's. There will be a situation wherein you will be left with some row or column that will not be able to accommodate 2 R's. Why is that the case? Think about it. Na? If I have 2 R's here and if I have 2 R's here already, then I have already chosen 4 different cells out of 5. Now, because I have chosen 4 different cells out of 5 in 2 successive rows, the third row cannot have those 4 cells coded as R. That leaves us with only one cell that can be colored R, and that's why the limiting condition comes. ठीक है, कोई भी दो रो ले लो, you will have 4 R's that will be present except the middle one. You will have 4 R's that are present, and that will limit the conditions that are there for the middle. ठीक है, so the correct answer here is not 10, the correct answer here is 9. So although theoretically we know that at most 2 R's can be present in each row, you will not be able to figure out or will not be able to place 10 R's across these situations. Okay. Someone is asking how exactly to be wary of the low accuracy sets. So Anshu, it comes with practice, honestly, right? So if you look at the questions, maximum possible, minimum possible, possibilities that exist, if then what will happen? All those questions which involve numerical data, wherein multiple, so 5 is also possible, 6 is also possible, 7 is also possible, 8 is also possible, सारे possibilities exist करते हैं, right? In that case, you need to know that you are in for some uncertainty. तो जैसे ही possibilities वाले questions आते हैं, wherein the parent information is not so much that you will be able to do something, but each question you are expected to solve afresh. That is basically when you know that you might end up in some uncertainty, not trouble, but some uncertainty. Okay. Next question: what is the minimum number of blue beads in any configuration? Okay. Minimum number of blue beads in any configuration के अंदर we know that two adjacent beads along the same row or column are always of different colors. So if I place a blue bead somewhere, right, the next bead that I am going to place will not be adjacent to it. That is what we are trying to say. Okay? That is one thing. The other thing that we have to figure out in this particular context is there is at least one green bead between any two blue beads along the same row or column. Okay? Now there are multiple things that you can think of. So let's say, for example, we start with some arrangement and we see what is the answer that we get, and then let's try to see if there is a better arrangement that exists. Right? I know that there is at least one blue and at least one green bead between any two red beads that are there, and there is at least one green bead between any two blue beads that exist in the same row or column. Now the first thing that we had seen, green, blue, green wala. Okay. So if I'm looking at two blues, 1, 2, 3, 1, 2, 1, 2, 3, and 1, 2. So I have 6 here and I have 6 here. I have a maximum of, or I have one case wherein I know for sure that 12 blue beads can coexist. Okay, if I just put everything as green, blue, right? But then let's say, for example, I take my 4 blues and I put these 4 blues here. Let's say, for example, okay, there needs to be at least one green bead between any two blue beads. So if I do it like this, what is the problem that will happen? In this case, I cannot put this as R. I cannot put this as B. So this becomes a G, right? Now this becomes a G. In this case, can I have this as an R? If this becomes an R, it is fine in this case. This one becomes an R, but I cannot have any other R in this particular. Okay? Even यहाँ पे, if I would have put an R, that would have been fine. I'll just erase this. I'll just show you the case with R. So sorry. Yeah. I could have put an R here, but then I would not have been able to put any other R here. But in that case, what would happen? I would have had to put a B here and I would have had to put a G here, and this would have again got violated. And that's why you could not have an R present in the second cell. ये वाले cell में R नहीं आएगा. So in that case, what would have happened? Just give me a second. In that case, what would have happened? The arrangement that I was sticking to was fine. So this will be a G. This will be an R. This will be a G. Similarly, यहाँ पे भी you can have the same thing purely because of symmetry. ये कर दूँगा. Now these two R's are, yeah, these two R's are separated by 3 units, which is fine. इसके अंदर you need to have at least one R and one. So let's say, for example, I put a B here, I put a G here, just for the sake of symmetry, nothing else. Right? Now I have 1, 2, 3, 4, 5 blues that are there. All these are green. There are some reds that are there and so on. Now, because I want to limit the number of blues in this case, just focus on the middle 5 terms now. Okay? Just because I want to reduce the number of blues in this case, what I have done is I have put greens here. But that means that I will have to put additional blues here as well, na? Because I put greens here, right? Because reds can't be present here, successive places. I will have to put some blue somewhere. right? So in this case, let's say for example, I put a blue here, okay, and I put a red here, and I put a red here, and I put a blue here. तो क्या हो गया? I have 1, 2, 3, 4, 5, 6, and 7 blues. So instead of 12, now my estimate has come down to 7. By now you would have realized that we're talking about symmetry in this case. Yeah, Piyush is saying that, can we think about it in this way? To minimize the number of blues, we have to maximize the number of reds and greens, right? You want to maximize the number of reds and greens, fair enough, you can do that. But वहां पे भी you might end up in trouble. So in this case, what you have to understand is, you have to figure out if there is some symmetry that exists. ठीक है? So in this case, symmetry exists करता है कि नहीं? That is what we have to see. अभी यहाँ पे 7 is already something that we have got. Now what is better than 7? 6. So we have to try if 6 is a possibility. Now again, you have to appreciate symmetry and you have to figure out whether you will be able to accommodate 6 blue beads or not. Now symmetry wise, if I'm looking at it, what is one way in which you can place 6 beads such that they are symmetrical to each other? Okay. So one thing that you can do in this case is, again, if you notice carefully, these 3 could be blue and these 3 could be blue. 6 करने के लिए, right? Now why these 3 blue, these 3 blue? One, I need to ensure that there is at least one green bead between any 2 blue beads along the same row or column. So I have to separate those blue beads by as much as is possible. ये करना चाहिए. So यहाँ पे, that's why I put these 2 and these 2 in the form of that plus, wherein they are separated by the largest possible amount. And the other 2 I have put so that they don't interfere with these, so that I don't have to worry about putting more greens, more blues, and so on. So this is what we have in this case. ठीक है? अभी यहाँ पे अगर if I have blues here, I want to make sure that there are as few reds or as many reds as possible rather, and they are separated by each other so that 2 reds have at least 2 between them, 2 cells between them. So let's say I go for this arrangement. अभी यहाँ पे again I go for these 4 red corners. Now all 4 of these are red corners that I have put here. All these are blues that we have. ठीक है? Now I do not really have any blues that are present here. जहाँ पे I am talking about or there aren't any 2 reds that are present here जिसके बीच में I want greens. ठीक है? Now what if I put all greens in these pockets? We don't have successive cells that are empty ना? तो सब जगह पे green डाल दिए. Now in this case, 2 adjacent beads are of different colors. Yes, there are different colors. All your reds are here. Yeah, so all your reds are here. All your greens are here. No 2 greens are adjacent, which means that no 2 blues will also be arranged, will not be adjacent to each other. So this is a feasible arrangement that we have according to this condition. There is always at least one green bead between any 2 blue beads along the same row or column. First row mein there is only one blue bead. Second row mein there is only one blue bead. Third row mein there are 2 blue beads, but they are separated by at least one green bead. Yes. Fourth row mein there is only one blue bead. Fifth row mein there is only one blue bead. So we have this covered. Vertically भी देखते हैं, there is only one column जहाँ पे you have to worry about there being one or more greens in between 2 blue beads. So in this case, again, think about symmetry in this particular. Yeah. So think about symmetry in this case. 6 is a possibility. So 6 can be our answer. Right? Can there be 5 blue beads in any configuration? ठीक है? So 5 blue beads का भी same issue. तो 6 वाला यहाँ पे कर दिया. So 6 is our best bet. 5 blue beads के अंदर again go for symmetry and see what happens. Right? So in this case, because you have 5 blue beads, you will have to have some red beads and some green beads. So यहाँ पे let's say for example you put a red bead, for example. If I put another red bead here, I will have to ensure that there is another blue bead here. तो यहाँ पे red bead नहीं आ सकता, right? So in this case, I'll again write all blues. So 5 blues. If I write it in the form of this symmetry, this one can't be a red, because if this is a red, you might have to have one more blue here to accommodate another red in this line, because I have only one blue. I have to have 2 colors here that are present. Okay. So in this case, let's say this is green. Same logic say this is green. Same logic say this is green. This is green. Okay. Now because this is green, this has to be a red, na? Now because this is red, this has to be a green. And now we have reverted to the first case that we had seen, जहाँ पे we spoke about those 9 or 7 blue beads that we had accommodated. and that is what makes this a suboptimal arrangement, right? So in these kind of cases, so I know for sure that you cannot be sure, right, of these question types. So in this particular case, because it's a theta question, you have to answer this. As soon as you find something which you are satisfied with, answer this thing and go ahead, move ahead in life. You have to always think about symmetry in these cases, right? Symmetrical arrangements will be your best. Agar symmetry nahi hai, if you are just grappling with things, 6 agar karna hai, and you come up with this amazing plan, wherein you are saying कि blue यहाँ पे करते हैं, blue यहाँ पे करते हैं, blue यहाँ पे करते हैं, and then let's do one blue here, let's do one blue here, and let's do one blue here. ठीक है? Now this may or may not work. I'm not saying this will not work, but then you are getting into too many possibilities, right? That's why don't go for cases जहाँ पे there is too much of खिचड़ी and all. अब यहाँ पे भी है. अभी this will be a green for sure. Now you know it for sure, right? अगर ये red है, ये red है. This is red. Let's say these two are green. Let's say it is still working. I'm not saying it will not work, right? It is still working. अब यहाँ पे green और blue है, यहाँ पे red आना ही चाहिए. यहाँ पे red आना ही चाहिए. This arrangement will not work. So ऐसा कर करके you will have to eliminate a lot of possibilities. So instead of getting into abstract cases, try to get into symmetrical cases. If it happens, it happens. If it doesn't happen, it doesn't happen. And as far as Adi, the question goes, is it advisable to leave such questions? If it's a theta question, no, not advisable to leave. Go for the optimal approach, go for a symmetry. And if even that doesn't work out, then you can mark something and let go. But try to go for as symmetrical cases as you can. That is the advice. And Joydeep, yes, you will have to draw the table multiple times. You will not have any option to erase unless you can smuggle a pencil and an eraser into the exam hall, which is a possibility. It depends on your center. What I would suggest is carry a pencil and an eraser. I generally carry a mechanical pencil and an eraser with me. If they check you and if they don't allow you to take it, fair enough. Let go of those 50 rupees that you have spent, sunk cost, koi baat nahi. But if they allow you to take the pencil and eraser inside the exam center, you can erase and rewrite the possibilities. Okay? Some people also advise taking multicolored pens to the exam center, but I would not tempt utna fate. Right? I might be more comfortable smuggling a pencil and an eraser into the test hall. Utna मैं कर सकता हूँ. उसके beyond, I don't want to become too obvious. Fine. Last question. Let's check once. 2 red beads have been placed in second row, third column. So second row, third column is here, and third row, second column here. These 2 red beads have been placed here. We have to figure out how many more red beads can be placed in the configuration. ठीक है, maximize करना है अपने को. Maximize कैसे करेंगे? We'll fill the entire diagonal first, because diagonally there is no restriction. Row column में restriction है. Now because red is present here, there cannot be any further reds in this particular row, in this particular column. But as we had seen earlier, what we can do in this particular context is we can maximize the other reds that we have, right? So earlier when we had seen this, we can figure out what is the maximum number of red beads in this configuration and how many more red beads need to be placed. Okay? So यहाँ पे 1 red was, 2 reds were already placed, बाकी अपने को place करना. So let's see what happens. So in this case, यहाँ पे no further reds are possible. In this column, if I want to place a red, I can place it here. But then I don't have any possible reds, any more reds that I can place here. Second row के अंदर there are no possible reds beyond this, because we need 2 reds to be separated by at least 2 places. तो वो नहीं हो रहा. So यहाँ पे we are full. In terms of the third row, I can have a red here. That is a possibility. In the fourth row, I can have a red either here. Only here is a possibility that exists. In this row, if I'm looking at it, यहाँ पे red नहीं हो सकता, यहाँ पे नहीं, यहाँ पे नहीं, यहाँ पे नहीं. You have to have a red. Okay? So if you are looking at this context now, I have 1, 2, 3, 4, 5, 6 reds that we have placed in addition to the 2 reds that were placed. So our answer in this case is going to be 6. Okay? Why not 7 and do the 9 wala arrangement that we have done? Because 9 wala arrangement we had optimized it in such a manner that I'll just show it to you once. Yeah, 9 wale case we were optimized it in such a manner that all the diagonals were live. But in this case, because our R's have been placed in such a manner that the diagonal has been invalidated, I will have to further optimize my outcome. So the correct answer here is going to be 6. We have 8 reds in total, but the question is how many more red beads can be placed. So total of 8 red beads, yes, but more is 6. So Manas, Jerin, although you have got the answer, you have not got the marks. That is the cruelty in life. All right. So that was the set that we had. We'll go to the last set. That is a manageable one. So we'll quickly go to the last one and try to see what happens. Manageable meaning it is difficult, painful, very, very, very painful. But there is a certain depth of logic that is in. Okay. So in this case, we'll try to look at what happens in terms of this scenario that we have here. So there are 3 reviewers, Amal, Bimal, Komal, who are tasked with selecting questions from a pool of 13 questions that are there. Yeah. So Joydeep, that was exactly the theme of today's session. These questions can take a lot of time. These questions are the ones where you will have low accuracy. You have to figure out what is your bet. So as I mentioned, I go into these sets with a 50% accuracy ka expectation. So if my expected value is 50%, I have 4 questions. Let's say I get 2 right, 2 wrong. I am getting a grand total of 4 marks. अगर मेरा DI के अंदर का expectation is getting 30 marks in or getting 24 marks in 40 minutes, right? 24 marks in 40 minutes का मतलब क्या हो गया? I am getting 0.6 marks per minute. I am intending to get 4 marks. So I can expect 7 to 8 minutes का investment in this set. उससे ज़्यादा investment मैं इस set में नहीं करूँगा. Which means I have to invest only 2 minutes in this set. In every question, sorry. Then I will be done. ठीक है, for the previous set is what I mean. ये वाले set के अंदर तो this is slightly different compared to the rest, but otherwise वो है. तो waste time नहीं करना चाहिए. That's what ना. 7 to 8 minutes is not wastage of time. Do your other sets first, and then the next decision making point जहाँ पे you come, prioritize these sets. At least you are able to do something. Answer right है करोगे पता नहीं. But don't go for the most difficult set. Go for these ones. Optimal solution for theta and move on. Yes, Rishi. That's what. So यहाँ पे थोड़ा वो let go वाला you have to be very comfortable with letting go of questions. ठीक है? So let's go for this question that we have. So there are 3 reviewers, Amal, Bimal, Komal, who are there, and we have they are tasked with selecting certain number of questions from a pool of 13 questions, and the questions questions can be created by external subject matter experts or one of the 3 reviewers. Now what happens in this case is either each of the reviewer will either approve or disapprove of whatever either they will approve or disapprove of whatever question has been given to them. Okay, and their decisions lead to an eventual acceptance or rejection of the question. Now if a question is created by an SME, बाहर की किसी ने question अगर create किया है, then Amal is the first person to review the question, and then the question is reviewed by Bimal. If both of them approve, then the question is accepted. Komal ka opinion doesn't matter because we have already got 2 green lights. If both disapprove the question, if both of them give red lights, it is rejected. Again, Komal is irrelevant here. But if one of them approves and the other rejects, one green light, one red light will mean that Komal will have to approve or disapprove it. If Komal approves, great. If Komal disapproves, out. Okay? So Komal is the tiebreaker. And the requirement is there should either be 2 greens or 2 reds. 2 green आ गए accepted, 2 red आ गए rejected, 2 green आ गए accepted. That's more or less sorted. Now a question created by one of the reviewers, right? So if a question is created by Amal, then it is first reviewed by Bimal, and if Bimal approves the question, then it is accepted. Meaning that Amal ने question बनाया है, तो Amal का already green signal, so Amal need not review it. Now if Bimal gives a green signal, 2 green signals will make it an accepted question. If Bimal says नहीं, ये मेरी तरफ से red signal है, I don't approve this question, then they will ask Komal, and Komal becomes the tiebreaker. So similar process compared to what SMEs did. Instead of SMEs, now someone is floating a question. Okay? Now again we have been told, अगर Bimal question create करता है, then first the question is reviewed by Komal, then it is reviewed by Amal. If Komal creates the question, then the first reviewer is Amal, and then if required Bimal. And 2 green lights have to be there for the question to be passed. 2 red lights rejected. Now again there are some facts that have been mentioned here. So many questions were rejected, so many questions were accepted after review. So many questions were reviewed by Amal, so many questions were reviewed by Bimal, and so many questions were reviewed by Komal. So that is what we know in this case. questions, if you look at it, there are 5 questions that are there. So CAT 21, there were certain questions that were there, 5 questions there. So how many questions were definitely created by Amal? How many questions were created by Bimal, and so on. So that is what we have in this particular context. Okay, so I think there are 6 questions. I just mentioned 5. It's fine, not a problem. So how many questions were definitely created by Amal? How many were definitely created by Komal? Definitely by the SMEs, definitely by disapproved by Bimal, and so on. So now it is obvious that I will have to make the entire table and then figure out what all questions have been asked to us. Okay. So let's look at the questions and then look at the solution as well. So to make my life slightly easier, what I have done is I have drawn this table. To make my life even easier, I have drawn the completed table as well, so that we don't have to struggle with the solution as such. So that is my safety net here, right? In this particular context. So here what we are trying to see is we are trying to look at what is going to happen in terms of these cases that exist, right? So just give me a second. I'll just configure this thing and then we will start, right? So yeah, all right. So let's look at what has been given to us. So question number 2, question number 6, 9, 11 and 12 were rejected. So question number 2 was rejected. Doesn't matter, but it was rejected, yes. Question number 6 was also rejected. The others were accepted. But this was done after the due diligence was followed, right? 9 was rejected. So 2, 6, 9, 11 was rejected. And question number 12 was rejected. So these 5 questions were rejected. The other questions were accepted. So fair enough. This we have taken care of. Amal reviewed only question number 2. So Amal reviewed question number 2. So Amal did not review question number 1. Amal did not review question number 5. 6 he reviewed. 7 he did not review. 8 he reviewed. 9 he did not review. 10 he reviewed. 11 he reviewed. 12 he did not review. 13 he reviewed. ठीक है, तो जो नहीं रिव्यूड किया उसको क्रॉस कर दिया है, एक्सेप्टेड एंड रिजेक्टेड को A and R करके we will write, right? So that makes our life easy. Bimal has reviewed only question 2. So question 1 Bimal has not reviewed. Question 2 he has reviewed. Question 3 he has not reviewed. Question 4 he has reviewed. Question 5 he has not reviewed. 6 through 9. 6 through 9 means 6, 7, 8, 9 ये सारे Bimal has reviewed. Question 10 he has not reviewed. Question 11 he has not reviewed. 12 and 13 Bimal has reviewed. Komal reviewed question 1 through 5. So 1 through 5, 1 till 5 सारे review कर लिए. Question 6 hasn't been reviewed. Question 7, 8, 9 has been reviewed. 10 hasn't been reviewed. 11 and 12 have been reviewed. 13 hasn't been reviewed by Komal. Okay. So now we have represented all the 4 facts that we had, and that is basically what we have in this question. Otherwise, whatever it is, we have to solve this particular. Okay. So now we have to figure out who was the creator of this question, and why do we have to figure that particular bit out? Because if you look at the questions that we had in the previous slide, how many were definitely created by Amal, created by Komal, created by SMEs, disapproved by Bimal, approval and disapproval. So 3 of them are on the basis of being created by someone, and that is what we have to figure out. Now, one broad question that you have to answer before you start with the solution, right? When would we know that a question has been created by Amal? Right? Amal has created the question, meaning what? Amal has created the question, meaning Amal would not have reviewed the question for sure, right? Amal would not have reviewed the question for sure. But Amal has not reviewed the question. Either Bimal or Komal or both would have reviewed the question. So if I'm talking about the first question, Amal has not reviewed the question. Agree. But Bimal has also not reviewed the question. तो अमल ने अगर क्रिएट किया है, if Amal has created the question, then what is the interpretation of that? कैसे पता चलेगा अमल ने क्रिएट किया है? Either Bimal or Komal or both would have reviewed the question, and Amal would have shown a cross. Okay. Again, I'm not saying we have to do this and keep everything in mind. I'm just talking about the possibilities that exist. What is the interpretation that Bimal has created a question? Bimal के सामने तो क्रॉस होगा in this case. So Bimal के सामने क्रॉस होगा, but then Bimal का question has to be reviewed by Komal for sure, and may or may not be reviewed by Amal. So Komal for sure, Bimal for sure, and Komal as well. So Bimal for sure or Bimal and Komal. Okay, so what I'll do is I'll just erase this and I'll just write it again. so that it's easier for us to understand. So I'll just erase all these things. AR is something that we look at in a bit of time. So what we are seeing in this case is Amal ने अगर create किया था, so Amal के सामने cross होगा, Bimal will definitely have something in front of him, and C will either have a cross or will have a tick or a blank. So tick कर देते. But B के सामने definitely tick होना चाहिए if Amal has created a question. Similarly, if Bimal has created a question, B के सामने there will be a cross, C will definitely have a tick, and A will have a tick or a cross depending on C का response. If B has created, C says yes, then A will not be relevant at all. So A would have not reviewed the question. Similarly, if Komal would have created the question, then in that case, sorry, Komal, K. In that case, Komal would have had a cross in front of her. A would have definitely had a tick in front of him. Why? Because Amal has to review the question. This tick is not about accepting or rejecting. It is only about reviewing a question or not reviewing a question. ठीक है? या दीपक, only Bimal or both. Correct, you're right. यहाँ पे only Amal or Amal and Bimal. तो ये possibilities. What if an SME would have created? If an SME would have created the question, Amal has to review the question whatever happens. Bimal has to review the question whatever happens. Komal may or may not review the question. ठीक है? So SME के केस के अंदर A and B have to review the question. Komal may or may not review the question. Now let's look at what has happened. Now which is the easiest among these two spots, right? A and B में tick होना ही चाहिए, and Komal में tick या cross में से कुछ तो एक हो सकता है, right? So in this case, I am saying that ये वाले केस के अंदर I am just putting up tick. Okay? I just put ticks wherein there are no crosses just to make our life easier. अब आगे जाके उसमें accepted or rejected we will put, which will make our diagram table messy. But for the time being, let's, ठीक है, ये वाले क्या अभी यहाँ पे SME ने create किया है, तो A, B and Komal would have all three of them given a tick, or A and B would have given a tick and Komal would not have reviewed that. So in this case, तीनों tick हैं. I know for sure that this has to be an SME. और कोई भी केस में तीनों tick नहीं है. Because if someone has created the question, right? If someone has created the question, then that person is not allowed to review the question. Na? Similarly, question 4 has definitely been done by an SME. Question 8 has definitely been done by an SME. तो तीन क्वेश्चन तो पक्का है जो SME ने किए हैं. Otherwise, what is another way of figuring out SME ने किया है कि नहीं किया है? A and B have a tick, but Komal has a cross. But if you look at Komal ka creation, there could be a situation then where A and B have both reviewed the question and Komal has a cross. So वहाँ पे I can't be certain that SMEs have done the question. So I can be certain that SMEs have created a question only if I have all three ticks. And I've already answered one of the 4 questions by doing this small bit. तो ये 3 SMEs ने किए हुए हैं, that is a certainty in life that we have. ठीक है? So I know for sure that these 3 questions would have been created by an SME. Right? So I hope this part is clear. So one answer आ गया, we'll mark it later, but we have it at this point. ठीक है? Now let's look at question 1. Question 1 के अंदर what has happened? The question has been accepted and there is only one tick. What does it mean? A question gets accepted only when there are 2 green signals that are there. But एक ही green signal पे question accept हो गया. This tells me that the question has been created by Bimal. Bimal has created the question and Komal has seconded it. So that's why the question didn't reach Amal at all. So Bimal has created it. Third wale mein, Bimal has been given a cross, but Komal and Amal are both ticks. So in this case, what all possibilities exist? Bimal के सामने cross है, Komal के सामने tick है, मतलब we are saying that Bimal has not reviewed the question at all. Now, if the question has gone to Komal without being reviewed by Bimal, then we can say for sure that SME has not made this question, because SME ka question goes from A, then to B, and then to K if required. So in this case, we know for sure that because the first 2 are not ticks, this question has not been manufactured by an SME. We know that this question has not been made by A, because if A would have made the question, A would not have reviewed it. It has not been made by Komal, because if Komal would have made the question, then she would not have reviewed it. So I know for sure that this question has been made by Bimal. ठीक है? अब वो accepted rejected we will do at a later point in time, but let's see who has made the questions. Ye wala. Again, this has been accepted, given a go ahead, has to have 2 green lights, but there is only 1 green light that has been given by Komal. So the other green light will have to be from the creator of the question. So question number 5 also has been done by Bimal. Abhi question number 6 has been rejected. 2 ticks, 1 cross. Yahan pe we had seen 2 ticks, 1 cross. 2 ticks, 1 cross can mean that it has been done by an SME. But is this the only case? Abhi yahan pe the other case is basically we are looking at Komal having created the question, because Komal ke samne cross hai. So whoever has created the question would not have reviewed the question. So in this case, Komal could have created the question. So according to Komal, there is a green signal. A बोलता है नहीं, red signal देता है. B बोलता है नहीं, मैं भी red signal दे दूं. Right? Now because Komal has given a green signal, Amal has given a red signal, Bimal's answer becomes the tiebreaker. And because Bimal has also given the red signal, this becomes a rejected question. So there is a possibility that Komal could have created this question. ये वाले case. Amal has not created or Amal has not reviewed this question. If Amal has not reviewed the question, then SME has not created the question. Because SME ने question किया है, तो Amal has to review that question first. But because Amal has not reviewed the question, this question has been created by one of these three and has not been created by an SME. कौन create कर सकता है? Amal ही कर सकता है ना? Because the other two are ticks. So Amal would have created this question. इसका story क्या होगा? That we'll figure out. Amal created the question. Bimal said no. Komal said yes. The question got accepted. 9th, Amal cross है, बाकी दोनों tick है. It's exactly the same case as 7th. So we know for sure that the 9th question would have been done in the same way as the 7th question by Amal. 10th question. It has been given a go ahead. Amal has reviewed it, but neither of the other two has reviewed it. SME का question को go ahead मिलने के लिए there needs to be at least 2 green signals, which means that in this case the question was made by Komal and Amal ended up accepting the question, and that's why Bimal did not have to look at the question at all. So the 10th question has been made by Komal, has been reviewed by Amal and has been given a go. 11th question. Again, Bimal को consider किए बिना ही दोनों को consider किया है, right? So tick cross tick ये वाला है. We had a tick cross tick here in question number 3. So we can say for sure that the exact condition is going to be replicated here. In this case, 11th question is to be created by Bimal or has been created by Bimal. Again, cross tick tick 9th में जो हुआ था वही यहाँ पे होगा. So Amal would have been the person who would have created this question. And last वाला question, if you look at it, 13th के अंदर tick tick cross में it was either SME or Komal. For the 6th question, it will be exactly the same thing, SME or Komal. Now mind you, I am only talking about reviews here. I am not talking about accepted or rejected. So यहाँ पे rejected question है करके कोई impact नहीं होगा. We are just talking about the creator and the number of reviews that were needed. ठीक है? And wherever there are multiple possibilities that existed, we had to consider those. Okay, question 3, Arjun, please repeat. So question 3 के अंदर I know for sure that अगर SME ने क्या होता, let's say for example SME did question 3. SME के अंदर प्रोसेस क्या होता है? If an SME has done a question, it has to go through A, तो A के सामने टिक होना चाहिए. It has to go through B, then whatever A says it has to go through B, and then if required it has to go through C. तो A और B के सामने टिक होना ही चाहिए in terms of whether they have reviewed the question or not. But in this case B के सामने टिक नहीं है, C के सामने टिक है. So I am sure that an SME has not done this question. अब question किसी ने तो बनाया ना, someone has made this question. An SME has not made this question, meaning that either A, B or C would have made this question. But if A or C would have made this question, they would not have reviewed the question. This tick mark signifies that the person has reviewed the question. And because यहाँ पे A और C के सामने, A और K के सामने sorry tick boxes हैं, tick marks हैं, I know that B is the one who would have made it, and that is why Bimal is the maker of the question. ठीक है, creator of the question. I hope it's clear. Now let's try to see what is the status. यहाँ से अपने को answers मिल जाएंगे. First 3 questions के answers अपने को इधर से ही मिल जाएंगे, and then we can go ahead and solve it. But let's look at the accepted, rejected status as well. So if someone accepts the question, we'll say A. If someone rejects the question, we'll say R. अभी यहाँ पे बिमल ने question बनाया है, and कोमल पे the discussion got closed, and the question was accepted. This means that कोमल would have accepted the question. तो हर टिक के सामने I need to have a status, right? अभी यहाँ पे SME दिया हुआ है. SME meaning that either both of them said it's right, go ahead with the same, or one of them said yes, the other person said no, because of which Komal ka answer became the tiebreaker. And tiebreaker में जो भी आएगा, that will basically be the status of the question, because that is the meaning of the tiebreaker. तो यहाँ पे Komal would have nicely rejected this question, which means that either Amal accepted the question or Amal rejected the question. Bimal would have accepted or rejected. तो यहाँ पे क्या होगा? Let's say SME made the question, Amal rejected the question, Bimal accepted the question, then Komal would have rejected the question. But let's say question banaya, Amal accepted the question, Bimal has to reject the question, na? So it's either A or R here and A or R here. Both of them can't be A's, both of them can't be R's. One of them has to be A, one of them has to be R. अभी यहाँ पे Bimal has created the question. Creator is Bimal. Komal and Amal, both of them have given their contribution. मतलब क्या हो गया? Komal would have rejected this and Amal would have accepted this. And because of that, this question got accepted finally. यहाँ पे SME का question है, it finally got accepted after going through all three of them. This means that Komal's response was the one which was the final outcome. तो Komal would have accepted. ठीक है? यहाँ पे again we are in the same eventuality. All three ticks. तो यहाँ पे A या R होगा, यहाँ पे भी A या R होगा. In fact, you can look at the 8th possibility as well. It's the same thing. A or R for Amal, A or R accepted or rejected for Bimal, and definitely accepted for Komal, because finally 8th question got accepted. ठीक है, तो ये तीन का status अपने को. Similarly, Bimal made the question, got accepted. It means that she would have accepted it. यहाँ पे if you look at it, question got rejected. SME या Komal ने बनाया था. If SME would have made the question, it went through A and B, which means that A and B both would have rejected. अगर SME के through गया होगा तो. अगर कोमल के through गया था, then Komal made the question, it got rejected, which means that Amal would have rejected and Bimal would have rejected. Right? So if it would have been through Komal, then Amal and Bimal, both of them would have rejected. If it would have gone through an SME, Amal and Bimal, both of them would have rejected. So I'll just put an R here in front of both of them. यहाँ पे Amal made the question and both of them underwent the question, तो ये reject हो गया, because the question has been accepted. Komal would have accepted the answer or question. Again, Amal manufactured it, same logic. यहाँ पे reject हो गया है, we can say that Komal rejected the answer, and this guy would have not accepted. अगर accept करता, then it would have been through. Both of them rejected. 2 red lights is what we need to reject the question. That is what we have to understand. यहाँ पे Komal made the question, got accepted. It means that Amal would have accepted. Bimal made the question, it had to go through iterations and it was rejected at the end. So both of them would have rejected. अगर rejected है तो 2 R आने चाहिए, 2 reds should be there. Amal ने बनाया, दोनों ने review किया, reject हो गया. Both of them have to reject. SME और Komal created the question. It went through Amal, it went through Bimal. SME ने बनाया था, it went through Amal, Bimal. End of the story. Both of them accepted. SME के through बना होगा तो Komal was not required. If Komal made the question, then what would have happened? Komal made the question and it got accepted at the end after going through Amal and Bimal. So Bimal would have accepted, right? So Bimal would have accepted the answer in case Komal would have done it. And in case of Amal, अगर कोमल ने बनाया था तो अमल रिजेक्ट किया, अगर SME ने बनाया था तो अमल ने एक्सेप्ट किया. So it's either R or A in terms of the first. ठीक है? Now this nice little messy table that we have drawn, we have drawn it in a neater format on a later slide, but this is what it looks like, right? So in the first case, Bimal was the creator. Bimal obviously accepted his own creation, but Komal agreed to it, and that's why the question went. Second वाले के अंदर SME would have made the question. It would have been accepted by Amal or Bimal and rejected by the other person. And because it got rejected finally, Komal would have been the one who would have rejected the question as a final जो भी tiebreaker. Bimal के case में same चीज. So that's what we have written here. So let's look at the final arrangement that I have done. This is exactly the same that I have done. Hopefully it's the same. So for 2, 4, 8 and 13, we have some ambiguity. So for 2, for 4, for 8 and for 13, we have some ambiguity in terms of who would have accepted or rejected someone else's suggestion. The other cases are all very clear. And यहाँ पे ये वाले दो situations में I know SME and Komal का there is some role that is there. Now we can look at the questions and we can figure it out. So Arjun, yes, this is lengthy but doable. So you have to be patient. So this is definitely not the first step that I would have done in this particular slot. But this is one thing that can be doable. With persistence, you know that you are going to get an answer. it's just replicating the logic that you have already figured in your head, right? So this is very important. The first bit that I mentioned here, if Amal would have created, then what would have been the outcomes? Although I didn't use the entire bucket that B will be a tick, K will be a cross slash tick, and A will be a cross, वो मैंने use नहीं किया directly, but even then I know for sure that this was something that I had to have in my mind before I started solving this set. Okay? So we'll just look at the questions now. How many questions were definitely created by Amal? So if I look at the data that I have here, Amal has definitely created this one. Amal has created question number 9. Amal has created question number 12. So I know for sure that these 3 questions would have been created by Amal. Right? So in this case, we know that these 3 questions were definitely created by Amal. Yeah. So 3 questions were created by Amal. That is the answer. So the answer to the first one is exactly 3 questions. Okay. How many questions were definitely created by Komal? So we have, this one is ambiguous, was not definitely by Komal. This one was definitely by Komal. So we know for sure that there exists exactly one question that would have been done by Komal. So the correct answer here is 1 that we have. Fine. Next, how many questions were definitely created by the SMEs? So this, as I mentioned, the first thing that we did for this set would have given us the answer. So how many questions were done by the SMEs? The correct answer is 3 questions that were definitely created by the SMEs. Next one, how many were definitely disapproved by Bimal? Now disapproved by Bimal matlab rejected by Bimal. So Bimal has to review the question and has to disapprove it or reject it. Okay, so यहाँ पे we have to figure out how many were disapproved by Bimal. So ये A या R we don't know, A or R we don't know. This is definitely rejected, definitely rejected, definitely rejected, definitely rejected. So there were these 4 questions that were definitely rejected or disapproved by Bimal, and so we will say that the answer is option C, that is 4 in this case. And the last question that we have for today, the approval ratio of a reviewer is the ratio of the number of questions she approved to the number of questions she reviewed. So approved A upon whatever were reviewed. So what describes Amal's approval ratio? So let's see how many Amal reviewed first of all. So Amal did not review this one, 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 did not review this one. So out of the 13 questions, Amal had reviewed 8. So 8 was the number of questions that were reviewed. We have to figure out which of the following best describes Amal's approval ratio. So we have to figure out what is the minimum number of questions that Amal could have approved and what is the maximum number of questions that Amal could have approved. So यहाँ पे Amal could have approved this one, maximum देख लेते हैं. So यहाँ पे Amal could have approved 2, 3, 4, 5, 6. So 6 was the max that Amal would have approved. And in terms of the minimum that Amal would have approved, जहाँ पे भी ambiguity है, we will offload that question. तो यहाँ पे Amal would not have approved, यहाँ पे Amal would have approved, यहाँ पे may or may not, तो may not पकड़ लेते हैं minima के केस के लिए. यहाँ पे may or may not, यहाँ पे definitely, यहाँ पे may or. So there exist 2 questions minimum that Amal would have approved. So it's going to be between 2 by 8 to 6 by 8 or 1 by 4 to 3 by 4, 0.25 to 0.7. Okay? So the approval ratio lies between 0.25 and 0.75. It's not either 0.25 or 0.75. Why? Because there could have been 3 out of 8. That could have been the approval ratio. So 3 out of 8 is neither 0.25 nor 0.75. It's 0.375. 4 out of 8 हो सकता था, 0.5 भी चलता, 5 out of 8 चलता था, 0.625, right? So either of these were possible. So it's between 0.25 and 0.7. So go for the best one. Between 0.25 0.75 में endpoints है कि नहीं है, don't worry about those things. This is the best option that we can go for. It's definitely not either 0.25 or 0.7. That much we know for sure. So out of the options that we have, the best option here is between 0.25 and 0.7. Fine. So that was the last question that I had from this set. There was one more question in this set. I'll try to tell you what that question was, and then we will see. So let me just check once if I have that question handy. Otherwise, also it's fine. If you make this table, you will definitely get the answer. So that is definitely not an issue. So the question was, how many questions created by Amal or Bimal were disapproved by at least one of the other reviewers? So created by Amal or Bimal. So Bimal, Amal, Bimal, Aman, right? So these are the 7 questions that are there. Out of these 7 questions, how many were disapproved by at least one of the other reviewers? तो ये 7 में से ये वाला नहीं है. This one was disapproved by one reviewer. So this is a possible answer. यहाँ पे there was no disapproval. In this case, there was one disapproval. So possibility. यहाँ पे both of them rejected in this particular case. So disapproval था, at least one disapproval था. Yeah. In this case, 2 rejects. In this case, 2 rejects. So I think in this case, the correct answer should be 5. So there existed 5 such questions which were created by either Amal or Bimal and were rejected by at least 1. Okay? So that gives us the answer. Now I'll just take a few questions and then I will close this session. So that was the answer. Any tips on whether I should focus more on mocks or on PYQs? Dharmaka, there is no reason why you should not be able to do both. What I would suggest is look at the CAT papers if you haven't till now, because those are the ones that will help you understand what exactly is the language that is used, what exactly happens at the CAT and so on. Of course, if you are taking SimCATs, you would have seen a glimpse of these sets in some test or the other. But beyond that, it's better for you to look at these tests. So prioritize your CAT papers if you haven't done it already. Look at CAT 17, 18, 19, 20, 21, 22. 6 साल के पेपर्स सारे देख लेना. That is definitely going to help you. But also take a few mocks here and there throughout the entire, right? Rupas, yes, that was a very clever trap that was there. Through वाला जो word था. So in the question there was this word through. Questions 6 through 9. 6 through 9 है, so it's not 6 and 9. It's 6, 7, 8, 9. So I again know a lot of people who made this mistake in that actual test as well. So because of that, a lot of people messed up. That is also. Okay. Ritika, am I going to solve all the DI sets? Not really. This is what I had planned for. Of course, if there is an overwhelming response to this one, I might end up doing one more as well. But this is what I had planned for. Mostly, I have spoken whatever I had to speak about the sets that were there. There is one session that was done by Parmeshwar sir. So he had spoken exclusively about set theory, Venn diagrams. So वो वाला session देख लेना. And there is one more session that is coming up tomorrow, which is by Amit sir, wherein he will talk about all those questions from recent CATs, wherein you did not have to solve the question to get to the answer, right? So all your substitution based, function based, option reverse engineering questions, all those he will be discussing in the next session. Okay? So that was my this thing. Yeah, that was my take on this thing. How many questions should we crack to reach the safest side of sectional cutoff? So Rahul, again, I'm talking purely in terms of 90 percentile ka cutoff. At least one set and 2 or 3 questions from the next set. At least, मतलब ये bare minimum है जो मैं बोल रहा हूँ. Sometimes scores get scaled downwards. In that case, you have to be confident enough of cracking 2 sets. So if you are someone, go with the mindset of being able to crack 2 sets completely, or if not, 1 entire set and 2 or 3 questions of the next set. उतना तो 7-8 questions का तो buffer पकड़ के जाना is what I would suggest. Of course, a lot depends on the perceived level of difficulty of your section and everything, but 2 का mindset लेके जा सकते. Any quick tips for quants? Dharma gave plenty of tips for quants. Make sure that you have seen all the past CAT papers. Don't go with a mindset. We already have a video on the common traps that people fall into when it comes to the quant section by Prasad sir. So have a look at that one. That comprises almost everything. Focus on arithmetic and algebra. Try to go through as many question types that you have already solved till now across mocks. That should help. Okay, chalo. All right. So I'll close the session now. Thank you everyone for turning up, and I hope you got to learn a few sets that you hadn't seen earlier. Whatever comments you have, just put it in the comment section below the video. I would love to hear from you. If you want another session, just let me know. If there is an overwhelming response, I'll not talk about the number of likes, comments, and so on. But if there is a good response to this video, then who knows, we might make one. Right? So do let me know what you thought about the session. And if there is any doubt, anything you haven't understood, let me know. I'll try to reply to it and answer to the best of my ability. Okay? Chalo. All the best, everyone. Thank you so much. And yeah, have a great evening.